Step 9, customizing the marketing mix. So we have already our target segment. We know the information which respondents are in our target segments and which are not in our target segment. This information is stored in the vector cl12.r, which we already constructed. And now we want to look at specific characteristics of our target segment and compare it to the remaining respondents, and for this we need additional information, and this is available in the dataset auth active desk, which is included in package MSA. So we load the dataset, which sort of contains the descriptor variables in addition to the segmentation base, which is contained in the dataset auth active. And this dataset, if we are interested in price, contains, for example, the information on spend per person per day of our travelers. And what we do here is we want to create a box plot which would allow us to compare the distribution of spend per person per day between the group of respondents in segment 3 and those who are not in segment 3. So what we need is we want to have box and whisker plots for that variable, spend per person per day, and we want it the data split by that categorical variable cl12.r, and this formula will be evaluated using the data argument here. So that variable spend per person per day will be taken from this data set. In our parallel box plot, we want to have notch equals true, which means the confidence intervals for the median estimates will be indicated. Y with equals true means that the segment sizes, the group sizes will be indicated. Because spend is right skewed distribution, we want to plot it on a log scale. So the y-axis will be on a log scale, and we add the y-axis label AUD per person per day. So let's look at the result here. If we zoom in, we see that this is the distribution of spend per person per day in Australian dollars for respondents who are not in segment 3, and these are those who are in segment 3. So from that point of view, we see that segment 3 members tend to rather spend more than the average traveler. So this is good news, so we don't need to cater for travelers on a tight budget. The next thing we might be interested in is, if we're interested in the place, is what booking channels people use for their accommodation and what would be then the right place to put information to. So we're using here the function prop bar chart from package flex class to do so. So prop bar chart takes here a matrix or data frame of binary variables, and then it splits each of the binary variables by that grouping variable G, which is our binary variable. Is that observation in segment 3, yes or no? The which argument allows us to select specific variables contained in that data set, and here we are only interested in variables which start with the names of the variables start with book. So the head here indicates we're looking for the character pattern book starting at the beginning of the string, and this returns us all the variable names which start with book, and these columns are selected in that dataset to create a prop bar chart. The layout is the information, how many panels do we want to have on one plot. So this means there will be just one panel. That's the x-axis label, and we want to ensure that the limits of the x-axis cover the whole range of 0 and 100%, which is possible. Let's look at the result here of that prop chart. So we see here that's the average indication of agreement that people use the internet for booking in segment 3, and the red dot is the population average. So again, we can compare the population average with the average in the segment. Here we have segment 3, so we just have one panel. That's because of the layout. And what we see is that again shading has been used. So some are grayed out, some are in color. full color, and this is based on the result of a test where we test is the proportion of agreement the same in the two groups or do they differ, and we run this test for each of the variables. And because this would inflate the p-value, so we'll get a lot of false positives, we correct for multiple testing, and then we use the p-values corrected for multiple testing, and this indicates that this p-value was smaller than 5%. Then it's gray, so we found a significant difference in the proportion of travelers stating that they use the internet for booking their accommodation in segment 3 than in the normal population. And similarly, we could do the same for the information channels. So this subselects from that data set the variables starting with info, and this gives us the exactly same plot just for the variables info. Looks exactly the same. We can compare average within segment to the population average with the dots, and we again have to grade out to see where are significant differences between the two groups and where the two groups have the same. We get here a warning indicating that the chi-squared approximation we're using for the test of equality of proportions might not be correct, and this occurs, for example, if we have here items which have very, very small agreement levels. In addition, for promotion, what we might also be interested in is which TV channel they look at. So that's a categorical variable which has more than 2 categories, and we could look at the mosaic plot if the distribution on preferred TV channel differs between respondents in segment 3 or not in segment 3. So we're using a mosaic plot for that, and par-las equals 1 indicates that we want to have the axis labels always horizontal. We'll see that in a moment. So that's just the mosaic plot. We add shading label for the x-axis title, and this gives us that mosaic plot. And make it bigger. We see here that's the distribution of preferred TV channel for respondents not in segment 3. That's the distribution for respondents in segment 3. The blue color here indicates that respondents in segment 3 are more likely to state that channel 7 is their preferred one, and that's valuable information for promotion.